Somewhere in the Everglades right now, a wildlife camera strapped to a cypress tree is capturing hours of footage of absolutely nothing. No raccoons waddling through the frame at dusk. No rabbits darting through the sawgrass. No opossums. No foxes. No marsh rabbits. None of the small, scurrying mammals that used to make this swamp feel alive at night. And that emptiness, that eerie, prolonged silence, caught on camera trap after camera trap across hundreds of square miles of wetland, is exactly the footage that has quietly stunned wildlife biologists working in South Florida. Not a monster, not a mutant, just absence stretching for miles where there used to be abundance. And the explanation behind that absence is stranger and far more consequential than almost anyone outside the research community realizes. To understand what that empty footage actually means, you need to go back roughly 3 decades. To a period when exotic pet owners across South Florida began releasing snakes they could no longer handle into the only wild space nearby big enough to swallow them, the Everglades. Somewhere around the mid-1990s, Burmese pythons, native to the swamps and forests of Southeast Asia, started showing up in Everglades National Park in small numbers. Nobody thought much of it at first. A python here, a python there, in a wetland ecosystem covering nearly 1.5 million acres. But Burmese pythons are not small snakes. They can grow past 17 feet in length and weigh well over 200 pounds. And more importantly, the swampy, subtropical climate of South Florida turned out to be almost a perfect match for the climate they evolved in halfway around the world. With no natural predators, an abundance of prey, and a landscape practically built for hiding an ambush predator, the color of dead leaves, the population didn't just survive. It exploded. By the time researchers began seriously studying the scale of the problem, the numbers were already staggering, and today wildlife officials estimate the established population sits somewhere in the hundreds of thousands, spread across a range stretching from just south of Lake Okeechobee down through the Florida Keys, and from western Broward County all the way into Collier and Lee counties. That's not a localized infestation anymore. That is an entire regional ecosystem, permanently altered. Here's where the empty camera footage comes back into the picture. Starting in the mid-2000s, wildlife researchers began systematically documenting something alarming happening to the Everglades mammal populations, using a method as simple as it is unforgiving. Driving the same roads at the same times year after year and counting how many live and dead mammals they spotted. In areas where pythons had become firmly established, the numbers didn't just decline. They collapsed. Raccoon sightings dropped by more than 99%. Opossum sightings fell by nearly as much. Bobcat sightings dropped by roughly 87%. And in the areas hit hardest, rabbits, foxes, and white-tailed deer fawns simply stopped showing up in surveys altogether, as though an entire tier of the food web had been quietly erased. Compare that to areas of Florida where pythons hadn't yet spread, where those same mammal populations remained healthy and stable, and the contrast became impossible to explain away as coincidence, habitat loss, or ordinary population cycles. Something was actively removing these animals from the landscape, systematically, region by region, following the exact same pattern as the python's own expanding range. That's the aftermath nobody saw coming when this whole thing started, not a python problem. An entire ecosystem quietly losing its middle layer of mammals, the raccoons and opossums and rabbits that everything else in the food chain, from birds of prey to alligators to the broader health of the wetland itself, had depended on for balance. Wading bird colonies, some of the most iconic residents of the Everglades, are now increasingly suspected of being targeted as well, as the pythons work their way up toward larger and larger prey once the smaller, easier mammals in a given territory have been exhausted. Frank Mazzotti, a wildlife ecologist who has spent decades studying the crisis at the University of Florida, has described the situation in blunt terms. These snakes disrupt the swamp's entire natural order, not through visible violence, but through slow, methodical, almost invisible removal. And that invisibility is precisely what makes this animal so difficult to fight. Burmese pythons are ambush predators, wrapped in a mottled brown and tan pattern that renders them almost perfectly camouflaged against the leaf litter and dense vegetation of the swamp floor. A python can lie completely motionless for days, blended seamlessly into its surroundings, waiting for prey to wander close enough to strike. Even trained researchers walking directly past a resting python in the wild routinely fail to spot it. In one of the more remarkable field demonstrations conducted for wildlife officials, a python coiled just a few feet off a well-used trail went completely unnoticed by a group of adults walking directly past it, close enough to touch. If professional wildlife handlers can walk past a python without seeing it, imagine how effectively that same camouflage works against a rabbit or a fawn, or a researcher trying to simply count how many snakes are actually out there. There's another layer to this invasion that makes it genuinely unlike most other invasive species stories, and it involves the one native animal in the Everglades powerful enough to occasionally challenge a full-grown python, the American alligator. For millions of years, alligators sat comfortably at the top of the Everglades food chain, with essentially nothing in the ecosystem capable of threatening a healthy adult. That changed the moment pythons became established in large enough numbers. Wildlife officials and researchers have documented numerous direct confrontations between the two apex predators, some ending with a python overpowering and consuming a young or moderately sized alligator, others ending the opposite way, with a large alligator managing to kill and eat a python that made the mistake of tangling with something too big to swallow. These encounters aren't just dramatic curiosities circulated on social media, they represent a genuinely unprecedented ecological situation. Two apex predators from entirely different continents with no evolutionary history of ever encountering one another, now locked in direct competition for the same territory, and, in some cases, treating each other as potential prey. Skip Snow, a longtime Everglades wildlife biologist who spent years studying the invasion up close, has pointed to these battles as some of the most visible, dramatic evidence of just how thoroughly the python has inserted itself into the upper tiers of the food web, just quietly picking off small mammals in the shadows, but occasionally challenging the swamp's most formidable native resident directly. The ripple effects extend even further than the missing mammals themselves. Raccoons, opossums, and rabbits weren't just prey animals occupying their own isolated niche. They performed essential ecological functions that the rest of the Everglades quietly depended on. Raccoons, for instance, are significant predators of turtle nests and alligator eggs, meaning their near-total disappearance from python-heavy areas has already begun altering nest survival rates for other species in ways researchers are still working to fully understand. Small mammals also play a role in seed dispersal, controlling insect and invertebrate populations, and in serving as a mid-tier food source for hawks, owls, and other native predators that suddenly find themselves competing with an apex predator far larger and more efficient than anything they evolved alongside. In ecological terms, removing an entire tier of medium-sized mammals from a wetland this large doesn't just create one obvious gap. It sends measurable disruption cascading in multiple directions at once, some of which won't be fully understood for years or even decades. That challenge, the sheer impossibility of finding an animal engineered by millions of years of evolution to remain unseen, is why the fight against Florida's python crisis has taken such strange and inventive turns. Traditional hunting and trapping methods barely scratch the surface of the actual population, so researchers have had to get creative. One of the most effective strategies to emerge involves turning captured pythons into unwitting spies. Scientists surgically implant small radio transmitters into male pythons, then release them back into the swamp during breeding season, when male pythons instinctively seek out females to mate with. Researchers then track the radio signal, following their released snake as it does exactly what evolution built it to do: hunt down other pythons. When the tagged male finally locates a breeding female, often coiled together with several other courting males in what's called a breeding aggregation, researchers move in and remove every untagged snake they find, sometimes catching a dozen or more animals in a single operation triggered by one radio-tagged informant. Scientists have taken to calling these snakes scout snakes, though the program's earlier, more evocative nickname, Judas snakes, borrowed from the biblical story of betrayal, captures the strategy even more precisely. One radio-tagged python effectively rats out its own kind over and over, sometimes for years, generating far more captures per hour of field work than any human hunter could manage alone. The scale of this ongoing effort is bigger than most people realize. Researchers with the University of Florida's Croc Docks Wildlife Research Lab, working alongside the U.S. Geological Survey, currently maintain roughly 24 actively tracked scout snakes across strategically chosen sites in Big Cypress National Preserve and the broader Everglades system, monitoring them several times a week through both older VHF radio tracking and newer GPS technology that reveals far more precise, detailed movement. Data. Field researchers Melissa Miller and Brandon Welty, who lead much of this fieldwork, spend their days wading through sawgrass and digging through dense brush, homing in on faint radio pings, sometimes with visiting lawmakers in tow to witness the process firsthand, as happened earlier this year when U.S. Representative Debbie Wasserman-Schultz joined a tracking expedition to see the program in action. Even with scout snakes doing the heavy lifting, researchers have experimented with almost every imaginable tool to try to level the playing field. Thermal imaging cameras designed to detect a python's faint body heat against the cooler background of the swamp. Detector dogs trained to sniff out python scent trails through dense vegetation. Pheromone lures designed to mimic the chemical signals female pythons release to attract mates. And in one of the stranger recent experiments, researchers even built a robotic decoy known informally as a robo-bunny, a mechanical stand-in designed to look and move enough like a live rabbit to lure a hunting python into striking range near a hidden camera or trap. None of these methods, on their own, has proven capable of meaningfully dropping the overall python population, a reality wildlife officials have grown increasingly candid about in recent years. That candor was on full display just this year, as Florida gears up for its annual Florida Python Challenge, a 10-day public hunting competition where roughly 1,000 participants fan out across South Florida's wetlands, competing for a state-sponsored top prize of $10,000 for whoever captures the most snakes. Wildlife officials openly acknowledge that this hunt, now running for multiple consecutive years, will not come close to eradicating the species. The python population is simply too large, too well established, and too well hidden for any single event, or honestly any combination of current methods, to eliminate. But officials maintain the hunt still serves a real purpose, removing individual snakes from the landscape, raising public awareness, and generating valuable data about where the population is thickest, even while acknowledging that total eradication is, at this point, almost certainly off the table. And the discoveries keep coming, each one reinforcing just how deeply entrenched this invasion has become. Earlier this year, a veteran python hunter working independently in the Everglades stumbled across 2 python nests situated right next to each other, containing a combined total of roughly 120 eggs. That single afternoon's discovery represented more potential future pythons than most organized removal teams manage to capture as adult snakes across several months of dedicated fieldwork, and it illustrates the core math working against every containment effort currently underway. Ecologists warn that even efforts as intensive as the Scout Snake program and the annual public hunts haven't come close to keeping up with the snake's own reproductive output, since one especially large female can lay dozens of eggs in a single clutch, and pythons reach reproductive age relatively quickly, compared to many other large reptiles. Florida has since classified Burmese pythons as a prohibited species, banning private ownership outright, and the federal government lists them as an injurious species under the Lacey Act, blocking their importation into the country entirely. Both measures aim squarely at preventing history from repeating itself somewhere else, even as the population, already established in South Florida, continues to defy every containment effort thrown at it. It's worth pausing on just how unusual it is for wildlife officials to be this candid about a losing battle. Government agencies don't typically volunteer the information that a signature conservation effort is unlikely to succeed at its stated goal. But researchers studying the python invasion have been remarkably consistent in acknowledging the scale of the problem honestly, rather than overselling incremental progress. That honesty matters, because it shapes how the public understands what's actually happening in the Everglades. This isn't a crisis being solved through a single innovative breakthrough or a particularly successful hunting season. It's a permanent alteration to one of the most significant wetland ecosystems in North America, one that researchers are now working to manage and slow rather than fully reverse. So where does that leave the Everglades and the empty camera footage that started this entire story? Wildlife officials aren't holding out hope for a single dramatic breakthrough that suddenly clears the swamp of pythons overnight. What they're working toward now is something closer to permanent, ongoing management, an acceptance that Burmese pythons are likely a fixture of the Everglades ecosystem for the foreseeable future, the same way certain invasive species have become permanent, unwelcome residents in ecosystems around the world. The Scout Snake program continues expanding. The annual public hunts continue drawing volunteers. Researchers keep refining detection technology, hoping thermal cameras, robotic lures, or some future innovation finally tips the balance, meaningfully in their favor. And all the while, those wildlife cameras keep rolling night after night, deep in the swamp, patiently waiting to see whether the raccoons, the rabbits, and the opossums ever start reappearing in meaningful numbers, or whether that unsettling silence has simply become the new permanent sound of the Everglades at night. What makes this story worth paying attention to isn't a monster hiding in the water or some singular shocking image caught on tape. It's slower, and in some ways more unsettling than that. It's the sound of absence, recorded patiently over years, revealing exactly how thoroughly a single introduced species can rewrite the rules of an entire ecosystem when it arrives somewhere with no natural predators and no evolutionary history to keep it in check. The Everglades didn't lose its wildlife in one dramatic event that made headlines overnight. It lost it slowly, quietly, one empty stretch of camera footage at a time, until researchers finally pieced together just how much had already vanished by the time anyone was watching closely enough to notice.